Alright, today we're using trig ratios solved for missing side lengths. Now, in trigonometry, this is actually the basis of what you're doing for all of trig. All we've done so far is actually identify certain angles and sides and stuff like that in our ratios.
Can you put the feedback so it
Why weren't you doing that already?
Exactly.
Okay. Alright, so, and now we're actually going to use the trigonometry to solve for stuff. Okay, so let's take a look at what I have here. So from this right here, so angle D is what here? 38, right? So angle D is my reference angle from here. This, what are the length of DF? So DF is going to be right here. Okay. Oh, wait, sorry, right here. DF is here. So that's going to be 17. And what are we trying to find? We're trying to find FE, right? We're trying to solve for the X. Or, if there is no X there, then I could actually just label it by the line segment, FE. So, now, let's take a look at the information I have and the information I'm going to use. So, this is my reference angle here. So, from here, this side is my class. What is that? Opposite. Very good. So, that's the opposite. So, I'm going to label it O. That's my opposite. Okay, the next one I label. Okay, here's my right angle. Across from that is my hypotenuse. There's my H. And then my third side is the adjacent. There's my adjacent now. Now, I have to look at what's given to me and what it's asking for. It's asking for the opposite, and it's given me adjacent. So I know I have to have opposite and adjacent in my ratio. So I'm going to flip the page back. Opposite and adjacent. Which one is opposite and adjacent? It's going to be tangent over here, right? Tangent is the only one that uses opposite and adjacent. This one uses opposite but hypotenuse. This one uses adjacent and hypotenuse. This one uses opposite and adjacent. So this is going to be a tangent problem. So now, it's going to be tangent of my reference angle. So you write it out like this. So it's tangent of my reference angle, which is 38 degrees, equals. Now, tangent uses the ratio of opposite over adjacent, right? So opposite of 38 was my X value, isn't it? There's my X. Over adjacent, my adjacent value is 17. Now from here we have to use algebra. Since I'm trying to find the X variable, so I want to isolate my X value. So I need to get rid of the 17. If the 17 is on the bottom of my fraction, what am I going to do to both sides of my equation? Multiply both sides by 17. So over here on the right hand side, what's going to happen to my 17? Cancel over here. So now I'm going to have 17 times tangent of 38 degrees is equal to X. Now, I have X by itself. Once you actually get to this point where your variable is by itself, then you can put it into the calculator. So I'm going to go ahead and do that. So I'm going to go, let's see, dot B to clear it out. You guys are probably going to have a whole bunch of stuff in your calculator right now. So for this one right here, So make sure your calculator is in degrees. It has to say DEG up in the upper right hand corner. Then I'm going to put 17 times my tangent. The tangent button is actually right here. You hit trig. So there's a trig button right there. It says trig, and then it opens up a little menu right here. And I want tangent. Put my 38 degrees, 38. Now, the degree symbol is down here at the bottom. Press the pi. You push the pi. The pi actually opens up another menu. And then there's my degree symbol. And I close that. Now, does yours look exactly like mine? Now I hit enter. And my answer is going to be, if I'm going to round this to a tenth, almost every single time, unless it says not to, you're going to round to the tenth. That's going to be 1 decimal point. So 13.28, that 8's going to make that 2 round up, right? So it's going to be 13.3. So my answer, x, is going to be about 13.3. And do I have any units here? No, I don't have any units on this one, but I'm just going to say u for whatever units I'm going to have. It's very, very good habit to always try to label your units, because a lot of our problems are going to be word problems in which you're going to be finding distances. So you're going to have to find those. Now, does this make sense? Did I lose anyone here? Hopefully it's not too bad. Now, let's take a look at this one right here. Steps for solving an unknown side. Label the triangle. Now, what is my reference angle here? It's going to be 40, so I'm going to start from here, right? So, if that's my reference angle, start drawing your arrows. I'm going to draw an arrow right there, so that means that this side is opposite. Draw an arrow this way, so that means that this side is my, and my third side is? Very good. Determine which trig ratio to use. Now, let's look to see. I have, okay, I'm looking for the opposite, and I have the hypotenuse, right? I'm looking for the opposite, and I have the hypotenuse. So what ratio uses opposite and hypotenuse? Sine? Yes. It's not sin, it's actually sine. It's abbreviated. So it actually says it right here on the top of the notes. So it's sine, cosine, and then tangent should be in here somewhere. Anyway. Sine. So now, let's set up our problem. If I'm going to set up my problem now, we said it's going to be sine. So I'm going to write sine. This time it's going to be sin because I'm abbreviating here. What goes next to that sine? 40. I have to put my angle. I have to put my angle. So that's my reference point. That's important. So it's going to be 40. What's wrong, Chris? Oh. Okay, so now, sine is opposite over hypotenuse, right? Okay, so opposite, what is my opposite value? X over 7, because that's my hypotenuse. Sorry, I really can't hear you. Oh.
I told him, I'm not going to ask this to make you sound more stupid.
No, don't. You know, seriously, we're starting something completely new. Most people have never touched this ever before. So ask a question because other people might actually have the exact same question.
I'll ask you.
Okay. All right, so this is set up. We're trying to solve for my variable, right? Now, I have my variables right here, and it's over 7. I need to try and get the variable by itself, so I'm going to multiply both sides by 7. Very good. Multiply by 7. So the 7's over here will cancel, so I get 7 times sine of 40 degrees is equal to x. Is my variable by itself now? Now I can enter it into the calculator. Seven times sine 40 degrees. It should give me 4.4995. So what is that going to round to? 4.5, right? So I'm going to say that x is going to be about 4.5, whatever my units are. Does that make sense or no? All right. Now we're looking at triangle JKL. JKL. Now, my reference angle. What's my reference angle here? 62, right? 62, we have that one. So I'm going to start there. Now that I have that, what do I label? Opposite. So I draw my arrow. This side is my opposite. Draw my other arrow. This side is hypotenuse. And my last side is? Okay, let's look. I'm solving for the adjacent, and I have the opposite. So opposite and adjacent is going to be tangent, right? Yes, so this one's going to be a tangent. So I'm going to write tangent. So we're looking for we have tangent here. So I'm going to write the equation. So it's going to be tangent. What's my angle? 62 is equal to, it's always opposite over adjacent on my tangent. If you guys look, you can go back. Opposite over adjacent. 24 over x. Very good. By what? Ooh. Now, whenever you're doing these, if you notice, every single time when I'm actually doing this, I try to multiply by the bottom. Because to clear out your fraction, you're going to want to multiply by the bottom here. Okay? Is everyone okay with what I have set up right now? Because I haven't even introduced what cotangent is. Alright. So, I'm going to multiply both sides by x. Multiply both sides by x. So over here, the x's will cancel. And I have x times tangent 62 is equal to 24. Now this is the point that I was actually trying to make. Is my variable by itself? No, it's not. What is my variable doing here? Multiplying, right? Class, am I paying attention here? I'm hoping everyone. So this is a multiplication, right? How would I undo a multiplication? Divide. So I'm not going to divide by x because I'm trying to get x by itself, so I need to get rid of this, right? I'm going to divide both sides by tangent of 62. So my tangent 62 over here will cancel, right? So now, once I cancel that out, I'm left with x equals 24 divided by tangent of 62. These problems right here are probably going to be one of the more complicated ones, but I guarantee you this problem is going to be on the test, like this. So, is my variable by itself?
Yes.
Yes. The variable is now by itself, so I can enter that in the calculator. So I'm going to do my control divide. 24 goes on top, and then tangent 62 degrees on bottom, right here. So I get 12.76. Now, what is that going to round to?
12.8.
It's going to be 12.8 because the 6 is going to make that 7 go up. So it's going to be x is going to be about 12.8 units. Does that make sense? Hopefully. A little bit. Alright, so let's take a look. We can solve the entire triangle. So, now that you know what x is, so solve for the hypotenuse. Now, if I know that this piece right here is going to be 12.8, okay, if I have two sides, if I know two sides of a right triangle, I would use what to solve for the third? Very good, Pythagorean theorem. And if I know this angle right here, these two angles together have to add up to how much? Not 180, all three add up to 180. So these two together are the complementary. Very good, complementary. We went over complementary yesterday. So they together have to add up to 90. So if this is 62, this other one is, how would I figure that out? 90 minus 62, right? 90 minus 62 is going to give me 28. So for that one right there, so this is going to be angle K is 28 degrees. Now, can I verify that? I know that the triangle, all three angles in a triangle have to add up to what? 180. Let's check to see if that actually does work. So we say 28 plus 62 plus, this box says that that is going to be 90. So let's add those together. There it is. It is 180. So knowing that these two are complementary, that helps me out to be able to find the third one. Okay, so now on our practice, you guys actually have a double-sided practice here. So if you guys look at this one, I'm going to help you guys set up the first one. Now, it's not labeled. It's not labeled here. So, for what we're going to do, we're going to go through and actually start solving for some of this. This one right here is my reference angle, right? Okay, if this is my reference angle, that means this side right here is my opposite. This side over here is? My last side is? Now, let's look to see what information I have. I'm looking for opposite, but I have adjacent. So what is that? Come on, class. Very good. Tangent. Tangent 22 is equal to? Tangent's always opposite over adjacent, right? So my opposite is? Over adjacent, which is? 5. Make sense? Okay. So, what you guys are doing today for your practice is going to be, you guys are going to do this one here, this one, this one, this one, this one, because tomorrow we're going to get into solving for the angles. And so you are only doing the ones that you solved the side. Tomorrow we're going to solve the angles. So you have 3 on the back. You have 3 on the back. And 1, 2, 3, 4, 5. 5 on the front. The back again? Alright. Let's see.